Hello friends, welcome to EPG Pathshala. Now in today's module number 27, we are discussing about internal and external ballistics, identification of firearms and ammunition. How can we identify firearms, and you are going to learn about what is internal and external ballistics. So first of all, we are discussing about what is ballistics. The term ballistics refers to the science of a travel of a projectile in flight. The flight path of a bullet includes travel down the barrel, path through the air, and the path through a target. There are three types of ballistics. These are internal ballistics, external ballistics, and terminal ballistics. What is internal ballistics? Internal ballistics is the study of what happened inside the firearm from the moment the trigger is pulled, firing pin hits the primer to the time until the bullet exits from the barrel. It is mainly concerned with propellant, pressures, acceleration of missile, while it is in the bore, muzzle velocity and recoil. When the firing pin strikes the primer, the priming compound explodes, causing an extremely high temperature jet of flame to pass through the flash hole and into the propellant charge. This jet of flame, which is about 2000 degrees Celsius, ignites the propellant powder, which burns at high speed to form a large volume of gas. This high pressure gas accelerates the bullet down and barrel and out the muzzle. Nitrocellulose, which is the main propellant in modern firearms, if ignited in an unconfined space, burns gently. If it is in confined space, the heat and the pressures built up will accelerate the rate of combustion exponentially. In a weapon, the propellant is confined within the cartridge case, the mouth of which is closed with a bullet. The round ammunition is then supported by the chamber walls and standing breech of the weapon. Under these conditions, the pressure build-up will continue until it is sufficient to overcome the inertia of the bullet and start its acceleration down the bore. The heavier the bullet, the greater the resistance and the higher the pressure. The higher the pressure, the greater the rate of combustion. And in external ballistics, what is external ballistics? External ballistics is the study of the missile's flight from when it leaves the muzzle until it strikes the target. The two main factors which affects the performance of a bullet on leaving the barrel are air resistance on its nose and the effect of gravitational pull of the earth. As a result of these forces, the bullet will, on leaving the barrel, describe a downward curved path or a trajectory. The exact shape of this trajectory can be predetermined by knowing the gravitational effect, the muzzle velocity, the angle of elevation of the barrel, the sectional density of the bullet, and the bullet shape. Next is terminal ballistics. Terminal ballistics deals with the behavior of the missile once it reaches the target. This is obviously not concerned with simply piercing a paper target, but what the missile does once it encounters a material considerably denser than air, while this will usually be concerned with the missiles. performance and wounding capabilities in animal tissue. This could be include its performance in water, soil, brick, concrete, wood, or bullet-resistant material. Terminal ballistics is the study of missile penetration in solid and liquids. It can be subdivided into penetration potential, which is the capability of a missile to penetrate various materials, and wound ballistics, which is the missile has on living tissue. So what is forensic ballistics? Forensic ballistics is the scientific analysis or interpretation of all ballistics related evidences with the purpose of interpreting and establishing the facts in a shooting related crime. Related evidences includes firearms or guns, bullets, cartridge cases. So, firearms in criminal investigation and trials are assuming an ever-increasing importance. This is mainly due to the following factors. Firearms are used in heinous crime. The evidence is accepted in the court. The evidence is permanent for all practical purposes. The evidence is demonstrative. Firearms are frequently involved in murders, attempted murders, accidental shootings, suicides, robberies, police firing, and police encounters. Unlike fingerprints, the identification of ammunition in respect of the firearm is definite. If a fired bullet is extracted from the dead body or cartridge case is recovered from the scene of occurrence, the same can be linked to the firearm positively in over 90% cases. So, we are discussing about the principle which is used in ballistics. First is the principle of individuality. The principle states that everything in this universe is unique. Neither nature has repeated itself, nor can man. It is well established that no two items in the world, whether natural or man-made, are exactly identical. This is easily understood and demonstrated in firearms. Second law is progressive changes or law of progressive changes. All firearms changes with the passage of time due to use or abuse, wear and tear, and weathering action of the atmosphere. This same is true of fired or unfired ammunition. Natural changes are ordinarily very slow. They remain ineffective and unnoticeable over a long period of time. Third lies the principle of exchange. Whenever two objects come in contact, there is an exchange of traces mutually. And next law is law of comparison. It says that only the likes can be compared is the law of comparison. We can compare only likes things. After that, we are going to discuss about the identification of firearm is based upon this basic idea. A harder object marks a softer one and imparts, transfer its microscopic irregularities to that object. Next is the identification of firearms and ammunition. Firearm identification is often treated as subspecialty of tool mark identification. A tool mark expert attempts to match tool like screwdrivers, crowbars to the marks they make when used on objects. Ballistics experts are more than tool mark specialists. They are generally expert in many aspects of firearms and testify about topics ranges from whether a specific object is legally a firearm to intricate reconstruction of scene of crime evidences. When investigators find a bullet at a crime scene, it can tell an examiner the caliber of the gun that fired it, the type of bullet, possibly the manufacturer and model of firearm. If police finds expanded cartridge cases, these also indicate the caliber of weapon used. Its type: rifle, shotgun, revolver, semi-automatic pistol, and possibly the firearms manufacturer. If police also recover a gun from the suspect, an expert would likely be able to match the bullet and cartridge case to that specific firearm. Experts can do this by looking at the mark the firearm makes on the cartridge and the bullet as it is fired. When a cartridge is fired, the firing pin strikes the primer. This impresses the firing pin's marks into the soft metal of the primer. The primer contains a tiny bit of explosive which, when hit, ignites the propellant. The propellant burns rapidly, producing gases that exert pressure in all directions. On the head of the cartridge case, on the wall of the cartridge case, on the bullet is the only part able to move and is forced out of the barrel, leaving the cartridge case behind. Most firearms have a rifled barrel. Barrel spiral grooves are cut into the inner surface of the barrel. The space between the grooves is called the lands. The grooves twist to the right or left. The number of grooves, their width and depth, and the angle of twist pitch vary by manufacturer. As a bullet passes through the barrel, it engages the lands, forcing the bullet to rotate. The spin acts like a gyroscope to stabilize the bullet and keep its nose pointed in a consistent direction. The spin makes the bullet more accurate over longer ranges. Because the bullet literally scrapes along the side of the barrel, the land and the grooves, impressions, and other microscopic details are etched into the side of the bullet. These fine microscopic details are called striation or stri. A cartridge case may also receive striated marks from the extractor and the magazine lips in firearms that have these features. According to Newton's third law, requires an equal and opposite reaction to any action. When a bullet is fired, the cartridge is pressed into the breech by the gas pressure. This impresses any marks on the steel breech face onto the back of the softer metal cartridge and the primer. The primer is also pressed back toward the firing pin, which may further impress its mark. The cartridge case may also be marked by the ejector in a firearm, which has this mechanism. These marks are called impressed marks. The marks which identify the gross properties of the firearm, caliber, number of lands and grooves, and the direction of rifling, twist are the firearm's class characteristics. The marks are often visible to the naked eyes. These will be the same for the bullet fired from any firearm of the same make and model, and often to several different makes and models, trying to match a recovered bullet or cartridge case to a specific firearm is more difficult. Firearm identification assumes that there are individual characteristics that are unique and consistent to one specific firearm. In theory, it is not possible to make two machine surfaces that are microscopically identical. Even rifled barrels manufactured consequently can be distinguished because the cutting and grinding tools are blunted and worn each time. They are used, leaving minute variations. Similarly, firing pins and the breech are believed to leave unique markings. Normal wear and maintenance, corrosion, rust, dirt and debris will change markings over time, creating both permanent individual characteristics and temporary accidental characteristics. These changes can make it easier to tell one firearm from others made by the same manufacturer. If a firearm is recovered, the examiner compares microscopic marks on the cartridge or bullet recovered from the scene of crime with test bullets and the cartridge cases fired from the recovered weapon into a water tank or bullet tray to see if the markings are consistent. If no weapon has been recovered, the examiner compares the crime scene bullet to each other and cartridge cases to each other to see if the markings are consistent. Forensic firearm experts can examine the following things. First, did a suspect use this gun to kill that person? Did these bullets come from that gun? Was it really self-defense? Is this a case of suicide or is foul play involved? Bullet comparison weapon function, is it safe? Has it been modified? Serial number restoration, gunpowder residue detection on clothes, hands and wounds. Muzzle to target distances. Pulling the trigger release the firing pin. The firing pin strikes the primer. The primer ignites the gunpowder and the powder generates gas that propels the bullet forward through a barrel and ejects the spent cartridge case. Next is the class and the individual characteristics of bullet and the cartridge or cartridge cases. Class characteristics are the position, the size and the general shape of the firing pin, the breech face, the extractor, the ejector and of the chamber marks on a cartridge are the class characteristics of the firearm. Class characteristics includes manufacturer, the shape, for example, whether they are rimless, rimmed, and was the caliber. Composition includes brass, steel or plastic. Which material is used for the manufacturing of the cartridge case? And the identification basis of the fired cartridge. The cartridge when fired comes in contact with relevant parts, the firing pin, the breech face, extractor, ejector and the chamber of the firearm. Firing pin. We are discussing about firing pin. The firing pin strikes the cartridge on the percussion cap and imprints its mark. The impact explodes the cap composition. The flame and the heat produced rapidly convert the propellant charge into gases. The high pressure developed presses the case against the firing pin. The clarity of the firing pin marks are thus enhanced. The firing pin marks produced on the base are equally useful. The firing pin marks alone permit the identification of the firearm is about 95% cases. Next, we are discussing about breech face marks. The surface of the action block surrounding the firing pin and opposite to the cartridge base in loaded gun is called the breech face. On firing, the gases push the cartridge case violently against the breech face, which imprints its negative profile on the cartridge base. The breech face profile is highly characteristic. It alone is sufficient for the identification of the firearm used. If the imprint of the profile on the base of the cartridge is clear and sufficient, the breech face marks are not always available. They are often absent on the cartridges fired from shotgun. They are generally imprinted when either the ammunition develops an abnormal high pressure or when the shotgun is defective. The ammunition fired from the improvised firearms frequently carries the breech face marks from the weapon, which is usually alone are sufficient for identification of the weapon. The high velocity rifles, automatic rifles and semi-automatic firearms ordinarily imprints identifiable breech face marks on the cartridges fired from them. Extractor marks. Extractor marks help in fixing the orientation of the cartridge in the chamber. The orientation is often helpful in locating the part of the breech block or another part, which may have imprinted the marks on the cartridge case. Ejector marks. In the automatic and the semi-automatic firearms, the ejector marks the cartridge case when it strikes against it in its backward motion. The ejector is so positioned that the fired shell after striking the device is pushed out of the firearm. The ejector marks are frequently identifiable and they link the fired shell with the firearm. The clarity of the marks, however, varies tremendously from one firearm to another and even from the shot to another in the same firearm. The marks firearm, they permit individualization of the firearm when the marks imprinted are sufficient and clear. The chamber marks are observed rarely on the fired ammunition. Ordinarily, some defects or some deposit in the chamber imprints its negative profile on the tubular portion of the cartridge case. When it's developed pressure on the firing, an oversized cartridge case may also tend to imprint with the chamber mark. The chamber marks are often found in the cartridges fired from the improvised firearm as there is no proper space to allow for the normal expansion of the cartridge case on the firing. The chamber marks permit the identification of the firearm from the fired ammunition like the other marks. Different weapons have different types of breech face marks. For example, Glock pistols possess a rectangular breech face pattern as opposed to a 9mm Luger LC pistol. Within the breech face pattern, there are minute impressions which can be identified microscopically. So friends, I hope you must learn a lot from this module about internal and external ballistics and how can we examine and identify or compare the bullets, the cartridge or the cartridge cases on the basis of their individual and the class characteristics. Thank you for watching this video.